Summarizing and graphing data. In real-world situations, you're often going to find that you're presented with large amounts of data when you're conducting an observation or a study. So for example, if you want to find out what lifestyle factors lead to heart disease, you may collect data from 100,000 patients, in which case you're going to have large amounts of data. Now, if you just list that data out, it's not going to be very informative because it's just going to be a bunch of numbers. And looking over 100,000 numbers, you can imagine, could get very tiresome. So how do we summarize and or graph this data so that we can gain some meaningful information from it? So the main thing we're going to focus on in this lesson is this idea of frequency distributions. So frequency distributions are sometimes referred to as grouped frequency distribution tables, or GFTDs for short. You may see this in the homework assignments. So suppose this is our data that we've collected from several females. This is the pulse rates that we got from them. A frequency distribution will show how the data set is partitioned by listing all the categories for that data and how many values are in each category. So I'm going to take all this data and split it up into these categories. My categories, my first category, for example, is 60 to 69. So I would look in my data set and find anybody who had a pulse rate between 60 and 69. I'm going to count those up. So between 60 and 69, of course, I have this one, 68, 64, 68, 68, 68, 68, 64, etc., etc., etc. I should have 12 of them up there. So I'm just counting up all the ones that are between 60 and 69. Again, I want to do that for all the ones that are between 70 and 79. On and on and on. And so my frequency distribution for these categories looks like this. I have 12 between 60 and 69. 14 of them were between 70 and 79. 11 of them were between 80 and 89. And then not very many were in the rest of these categories. So it's safe to say that most people, most women, will have a pulse rate between 60 and 89 just looking at this frequency distribution. So that's one thing I can get from summarizing the data that I might not have been able to tell right off the bat just looking at the numbers alone. So let me zoom in on the first two rows of that frequency distribution. 60 to 69 had 12 occurrences, 70 to 79 had 14 occurrences. I'm going to define these a little further. So we call these on the left side my classes, 60 to 69 and 70 to 79. The number on the left is the lower class limit, and you can guess the number on the right is the upper class limit. A few more definitions related to frequency distributions. We have class boundary, which is a number between the upper class limit and the lower class limit of consecutive classes. So that is, if I want to find the class boundary between the first and second class, I need to find a number between the upper class limit of the first class and the lower class limit of the second class. So a number between 69 and 70 would be 69.5. The class midpoint is the number in the middle of a class. So to find that, we just add the upper and lower class limits and divide by 2. But you might be able to do this just looking at it. The number in the middle between 60 and 69 is 64.5. The class width is the difference between two consecutive lower class limits. So the class width between the first and second classes is the difference between 60 and 70. So in other words, my class width is going to be 10. Now I said between the first and second class, but that class width should stay the same between any two consecutive classes in a frequency distribution. So the class width of all of these classes will be 10. Now don't make the mistake of thinking the class width is the difference between the upper and lower class limits, in which case you would get 9. It's the difference between lower class limits of consecutive classes. So 70 minus 60. So in this example, we have the class boundaries for all of our classes are 59.5, 69.5, 79.5, 89.5, 99.5, etc. Now notice the two that might be confusing are the 59.5 and the 129.5. All of them are between the upper class limit and the lower class limit of consecutive classes. But we do throw in 59.5, which would be below 60, and 129.5, which would be above 129, just for completeness. So we do include those in the class boundaries. The class width, of course, is 10. What about the class midpoints? Well, straightforward, we said that the class midpoint for the first class was 64.5. The class midpoint for the second class in this case will be 74. On and on and on for each of these classes. So let's take a look at this example. Use the frequency distribution to identify the following: the lower class limits, upper class limits, the class boundaries, the class midpoints, and the class width. Well, the lower class limits for each of these classes will be 10, 14, 18, and 22. The upper class limits, of course, are 13, 17, 21, and 25. The class boundaries will be the numbers between the upper class limit and lower class limit of consecutive classes. So we'll get 13.5 between 13 and 14, 17.5, 21.5. But also don't forget to include the number below 10 and above 25 going in the same pattern. So we would have 9.5 below 10 and 25.5 above 25. This would be my list of class boundaries. The class midpoints then are going to be 11.5, 15.5, 19.5, and 23.5. Of course, those are the numbers that are in between or in the middle of each class. Now the class width will be the same for each class, so we'll only get one number here. And to do that, I simply look at my second and first class and say 14, my lower class limit for my second class, minus 10, which is my lower class limit of my first class. Subtract those and you get 4 as the class width. And again, that should be the same for each class. Now we'll talk about how do we actually construct a frequency distribution given some data. So suppose this is our data, and it's the heights of males from some population. Our instructions are to construct a frequency distribution with 4 classes. So the question is, how big should those classes be? Now the class width of each class has to be the same for a frequency distribution. So what we do is first calculate the class width. And we do this by taking the largest data value minus the smallest data value and then dividing by the number of classes. So in this case we were told to create 4 classes, so we're going to divide by 4. So our maximum data value in this case looks like it is going to be 79, and we would subtract off the minimum data value, which in this case is 60. Divide by 4 gets us approximately 5. Now whatever we get a decimal most of the time. We always want to round up. And for our purposes, we'll always round up to the nearest integer. So now that we have a class width of 5, we can start making our table. And to do this, we want to start with the minimum data value as the lower class limit for our first class. So in this case, our minimum data value is 60. That's going to be our lower class limit for our first class. Now step 3, we can add the class width to that lower class limit to get the next class's lower class limit. So we start out with 60 as our lower class limit. We add our class width of 5 to get the next lower class limit. And then add 5 again and 5 again until we have all 4 of our classes' lower class limits. Now our upper class limit is going to depend on our data. So if our data had 1 decimal, I would go to 64.9. If our data had 2 decimals, I would go up to 64.99 for my upper class limit of my first class. So for however many decimal points your data has, that's what you want your upper class limit to be going to, that many decimal places. In our case, in this particular case, we don't have decimals. So I can safely go to 64 as my upper class limit for my first class. And 69, 74, and 79. Step 5 now, count how many of each of our data go into each of our classes. So how many of our data are between 60 and 64? 2. That is, the 64 and the 60 are between 60 and 64. Now, how many of that data are between 65 and 69? Well, looking through here, 72 is not, of course. 69 is. 64 is not. 68 is. And 67 is. So it looks like we have 3 that are between 65 and 69. Now, between 70 and 74, we're going to have 4. And between 75 and 79, we're going to have 1. Now, one possibility for checking to see that you didn't make any grave mistakes, if you add up your frequencies, that total should be the number of data that you have. So in this case, if I add these up, I get 10. I also have 10 data points. So it's not a guarantee, but at least I know I didn't make any huge mistakes because I've got all my data represented in this frequency distribution. 10 data points and 10 frequencies. Try this one on your own. Pause the video so you can have enough time to try it. Construct a frequency distribution with 3 classes. So start out first calculating the class width, then figure out what is the lower class limit, then add that class width twice to get the next lower class limits, and then from there get the upper class limits. And keep in mind, we only need integers because our data only has integers. And then finally count up for each of those classes how many of our data fall into that class. Again, pause the video and try it. Alright, here's what I got. I got a class width of 3, so my lower class limits are going to start at 25 because 25 is the smallest number in my data set. My next lower class limit then is 28 and then 31. And because I only have integers, my upper class limit will be 27 for my first class, and then 30, and then 33, following the same pattern. And then finally, I just have to count up how many are between 25 and 27, between 28 and 30, and between 31 and 33. And again, just as a quick check, I add up my frequencies and I get 12. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. So I can rest assured that I didn't make any grave mistakes. So a relative frequency distribution is very similar to what we've been talking about, frequency distributions. On the left, I have my frequency distribution, and I want to take that and create a relative frequency distribution. To do this, I start out by adding up the frequencies. And again, keep in mind, this is how many data points I had. Now to get the relative frequency, I simply take the number that was in my frequency and divide it by the total of my frequencies. So for my relative frequency for the first class, I simply take 2 divided by 12, and I get 0.167, and I can convert that into a percentage as 16.7%. Now, a relative frequency distribution, you can either decide to have a percentage or leave it as a decimal as 0.167. But it's pretty common to be consistent. So if you decide to stick with decimals for the first one, stick with decimals for each of these. And if you decide to stick with percentages for the first one, stick with percentages for each class. So I'll do the same thing for the second class. Now I take my 3 and I divide it by 12, and I get the percentage 25%. Do the same thing with 4 divided by 12, and I'll get 33.3%. And lastly, do the same thing with 3, and of course I already did 3 divided by 12 and got 25%, so I know this one will be 25%. So one way to interpret this is that 25% of the data was between 75 and 79. 16.7% of the data was between 60 and 64. So if we did this right, we should be able to add up these percentages and get a total of 100%. Or if I was in decimal form, I should be able to add up all my decimals and get 1. Now there may be some rounding issues, in which case we may get 99.9% or 100.1%. Or decimal, you might get 0.99 or 1.01 due to rounding. So it might not be exactly 1, but as long as you're very close to 1, chances are you did it correctly. So this is now our relative frequency distribution. And to be fair, I may not list these things, just the percentages would be the relative frequency distribution. Consider this example. The 2,472 people aboard a sunken ship included 465 male survivors, 1,484 deceased males, 443 female survivors, and 80 deceased females. Complete the following relative frequency distribution. Note, we're doing something slightly different than what we did in the previous examples. We're using categories instead of classes. So we're not using intervals for our classes, we're using actual categories. But we can still create a relative frequency distribution. So what I'll do first for my first category is take the number of male survivors, because that's the first category, and divide it by the total number of people that were on the ship. So 465 divided by 2,472 is approximately 0.1881. Now I could leave this as a decimal and have that be my relative frequency, or I could change it to a percentage, which I'll do in this case. So let me do the same thing with my deceased males. I'm going to take the number of deceased males, 1,484, and divide it by 2,472, and I'll get 60.03%. I'll take my number of female survivors, 443, and divide by 2,472 and get 17.92%. And then for the last category, take my 80 deceased females and divide by 2,472 people on board to get 3.23%. Now just to double check, you can add up these percentages and make sure that it's approximately 100%. So the last type of frequency distribution we'll talk about is what we call a cumulative frequency distribution. And this takes a class, but instead of asking how many of our data were in that class, we're asking how many of that data were below the lower class limit. So for example, for my first class of my cumulative frequency distribution, I'm asking how many of my data were below 65? Well, of course, that's going to be all the data that was in the 60 to 64 class. These would have had data below 65. For my second cumulative frequency distribution class, I'm asking how many of my data were below 70. So of course that will include all the data that was between 65 and 69, so all three of these, but also between 60 and 64 because these data will be below 70. So that is, I'm adding up all the ones that were in the first class and the ones in the second class. That is, there were 5 that were below 70. So to get the number that were below 75, I simply add the next number to it. So add 4 to this 5. So there were 9 that were below 75. And finally, to get the last class in my cumulative frequency distribution, I'll add 3 to this 9 because there were 12 that were below 80. So a cumulative frequency distribution simply adds the next class to each class in my cumulative frequency distribution. A normal frequency distribution is one where the frequencies start low, they get bigger, and then they get small again. Also, they are roughly symmetric. So if we look at this frequency distribution, we start low, we get bigger to 29, and then we start going low again. However, I wouldn't say that this one is a normal frequency distribution or even approximately normal, because we started out at 2, but we ended at 27, and those are fairly different. So even though we started low, got big, and then went low again, this isn't symmetric because this last one is not close to the first one. Looking at this second example here, I started low, I got bigger to 27, then went down to 26, 14, and then to 1. Now because the first and the last are similar to each other, the second and the second to the last are similar to each other, and the third and third to last are similar to each other, I would say this is roughly symmetric, in which case I would say that this is a normal frequency distribution, or at least approximately normal.